Okay, folks, I already did problem number one. We didn't have a whole lot of mistakes here on problem one, so I'm showing how I plug 2 in for x. I get 18 on part A. If you would check for me, though, your part B, make sure I graded it correctly, and your part C in particular, because it was hard for me to see some people's writing on this. Could I clearly look at it and see each one of the terms? I tried to eyeball it and see if it looked correct to me. You may have lost some points here on part C, so please take a look and see that you have the correct answer. On number two, what people kind of messed up on is interval notation. Interval notation is where we're using the parentheses and the square brackets. So when I put a parenthesis here, I'm saying I don't really want -9. I want to start as close to -9 as I can, and then I want to go out to positive infinity. And you never reach positive infinity. There's no number called infinity, just an idea, bigger and bigger numbers, and so you put a parenthesis right here. On number three, the domain, you have to keep 3x greater than or equal to 0. I don't know if I said this back here. We have to keep x plus 9 greater than 0 because you can't have a 0 in the denominator and you can't have a negative underneath the square root sign. So you want it to be greater than 0, not greater than or equal to. But down here it can be equal to because we're not dealing with a fraction. We're just, we can take the square root of 0. You just can't have a negative in there. So do you see how it changes from a parenthesis to a square bracket on this one? Interval notation again. I thought you guys have made a lot of progress. I know you guys have made a lot of progress on these difference quotient problems. So I'm plugging x plus h in for x, and I expand it. And then I took the opposite of f of x right here, and I kind of lined them up. I don't know that I did my work that often like this on the whiteboard. I just stuck them next to each other, but maybe lining them up vertically will help people see those two terms go to 0, x squared and the 5s, and then you have 2xh plus h squared left. This is the numerator, okay? That's just what's in the numerator. In the denominator, see, we got an h down in the denominator, so if I put an h in the denominator, h will divide into here, h divides into there, and what are we left with over here on this term? 2x. And then what are we left with on this term when we divide h into here? We're left with 1h. So we got, just plain h right there, 2x plus h. All right, on this strictly increasing, we had more people miss this guy than maybe any other question. Let's see if this makes sense. Okay, so I'm going to highlight stuff that's increasing. All of that stuff's increasing. This stuff right here is increasing. And this stuff right here is increasing. And what I want to show people is the x values over which that's happening. So where does that yellow highlighter start? It starts at -8 and it goes all the way over to -2. So in order to represent that interval, I'm going to put down -8 over to -2, and I'm going to put a parenthesis because we don't really want to include the minimums and the maximums. If you put the square bracket, it's not really increasing or decreasing down here at this bottom point. It's doing neither one. So, all right, so we also want the points that are going from here to here. Right, so that's from 1 to 3 in the x direction. So the way I do that is I go 1, 3, and then I go union, and we want to go from 5 out to infinity if you think the function keeps going, or from 5 to 10 if you're just trusting what you see in the graph. So I liked either one of those answers. I'm going to go 5 to 10 for now. 5 to 10 square bracket. You could have, obviously, you could have 5 to infinity right here, and I think it's very justifiable. All right, on number 6, what we were looking to do is if something is even, it's symmetric about the y-axis. So let me put down here y-axis, and then down here for odd, it's origin. Now for the origin, because I have a little bit more space over here, if you have some point x, y, there's also got to be a point -x, -y. So that's what I'm going to try to show right over here. I'm going to say negative g of x, that's my -y right there, is equal to 7 times -x cubed plus 2. So what should happen is if I plug a negative x in and a negative y, do I have it going right back to the original function? Does it look identical to this after I simplify all this stuff? So let's try it. Negative g of x equals negative 7x cubed plus 2. I multiply both sides by negative 1, and I get g of x equals 7x cubed minus 2. Not identical because we have this minus 2 where we should have had the positive 2. Okay? So this is not odd. All right? Now let me try that with even. If I have some x, y, I should have a matching negative x, y. So let's do that. G of x, does it equal 7 times negative x cubed plus 2? I get g of x equals negative 7x cubed plus 2. Not the same thing because we now have a negative 7 right here when we should have had a positive 7. So this one is not even. All right, so that's the corrections for the first page, the front page of our test. Watch the second video to see all the corrections on the back side.